Hi, dear audience. I'm Zhulei, a PhD student at the City University of Hong Kong. Here I present our CVPR 2023 paper titled BiFormer, Vision Transformer with Bi-level Routing Attention. Here is the outline of my presentation. First, motivation. In the recent 2 years, transformers that originated from NLP have also become the de facto architecture of state-of-the-art vision models. However, as the core building block of transformers, scaled dot product attention, or SDA in short, is a double-edged sword. While it enables modeling long-range dependency and the dynamic aggregation of information, it suffers from quadratic computational complexity due to global pairwise interaction between vision models, vision tokens. There are several works that introduce the sparse attention to reduce the computation burden of SDA. However, they either use handcrafted sparse pattern, such as restricting attention inside local windows, axial strips, or dilated windows, as shown in B, C, and D. Or they use shared query agnostic sparse sampling, such as here. So can we have a dynamic query aware sparse attention? In fact, according to visualization of DTR and VIT, we can clearly see the attention heat map is query dependent and non-local. On the left side, here is the official DTR visualization demo. Red dots are query position, and the corresponding attention heat maps are surrounding. We expect the dynamic sparse pattern better approximates the full attention here. And here is our methodology. Basically, we introduce a cost-to-file scheme named the bi-level routing attention, or BRA in short. First, we divide some image into regions and compute region-level features using average pooling. Then, we perform coarse region-level routing by computing a region affinity followed by top-K specification. Finally, we gather scattered key value paths and then do figure-rate token-to-token attention as normal. Note that with key value path gathering, there is only GPU-friendly dense matrix multiplication. And unlike masked attention, computation corresponding to zero entries are skipped. The core logic of BI is simple, and it can be described in several lines of pseudocode here. So what's the complexity of BI? We also provide an analysis. The high-level intuition is that with larger region partitioning factor S, there is more computation on the routing because more regions, and less computation on the figure-rate token-to-token attention because less key value paths to attend per query. And the conclusion is that if we scale S according to the resolution in such a way, we got a complexity like this. To verify the effect of bi-level routing attention, we follow recent SOTAs to use a hierarchical architecture design with BRA at the core. We conduct experiments on classification, object detection, and semantic segmentation. BiFormer have achieved decent improvement compared to recent SOTAs. We also conduct ablation study on the sparse attention mechanisms, the partitioning factor S, and the number of the regions to attend K in our BRA, and the other architecture designs. The conclusions are here. Here is the realization of bilevel routing attention. We demonstrate two things. BRA captures long-range dependency and the semantic dependency in a parallel manner. And we do know there are some limitations. Actually, compared to the flops, the throughput does not look as good as it. This compared to sparse attention with handcrafted regular pattern, for example, local window or axis strips, as we listed before. BI introduced an extra step to locate regions to attend, while it does not introduce much computation overhead. It requires more memory transactions, for example, by the gather operation, and more GPU kernel launches. And as a result, the throughput decreases. But it actually can be improved via engineering efforts such as kernel fusion. Besides, there may be also some interesting research problems. For example, when the sparsity can be ideally utilized to accelerate the computation. And finally, it comes to our conclusion. We propose bilevel routing attention, a novel dynamic query with aware space variant of scattered dot product attention. It achieves complexity of such with proper region partitioning size. Using BRA as the core building block, we propose BiFormer, a family of vision transformers, which achieve better flops accuracy trade-off. And the limitation of BRA. So more details can be found in our paper and code.